And today we're going to talk about a plug-and-play approach, and 3 key words: plug and play. So this is runs essentially as a utility or a software appliance, if you will. You set it up, you configure it, and you let it do its thing. It doesn't involve changes to the environment. It doesn't involve long projects, long learning curves. It's very close to an instant start to a return on your investment. And the product is called QuickSelect, and the name kind of says it all. We accelerate the performance of select statements. So QuickSelect for Db2, plug and play performance in savings. The big picture: what does QuickSelect do? It sits between your programs in Db2. This is at a conceptual level. And it's observing the flow of Db2 SQL statements as they head toward Db2, and it's observing that river of statements, if you will, for patterns of repetitive, unique, static SQL statements with the same host variable, right? And where you have the same SQL statement with the same host variable, what do you get in return? You always get the same result set. So we're observing the workload for these patterns of repetitive requests. And when we see these, we cache the corresponding unique result sets outside Db2 in memory above the bar. The next time we see one of these unique queries heading toward Db2, we will intercept it and we will serve that SQL, the result set, directly from our cache, avoiding the relatively expensive round trip to Db2, offloading that work from Db2.
Hey, Mark.
Yes, sir.
Are we able to record this session?
I can certainly do that. Let me turn on recording right now.
And Mark, I think Sweeney was dropped from the call and needs back in. If you can allow her back in.
Thank you. I'll do that right
now. And
now.
also Faina is trying to get in.
Well, it looks like we have 3 people. Okay, there we go. And let me find the record button here. Actually, what I'll do is I'll record it offline outside of Zoom, and then I'll send you all a link whereby you can download the presentation. The mail will be from a service called Jumbo Mail, and it will simply contain a link that you can click on.
Excellent. Thank you.
You bet. So result sets are then served from QuickSelect cache and not Db2. Surprisingly, there tends to be, particularly in the insurance industry, a lot of this kind of traffic. Now, QuickSelect cares about these sorts of static SQL statements going against relatively stable tables, reference tables, lookup tables, code tables, price tables. In a typical insurance company, you probably have 100 to 200 of these scattered across your various applications. And what we've learned is that in insurance companies with a fair amount of static SQL, there's a lot of this kind of repetitive traffic. And we can show you this during a proof of concept. So we have the ability, without actually turning on the product in production, to capture statistics that point at this repetitive traffic. So you can gauge, to what extent is this prevalent in your environment. Actual benchmarks. These are round figures, but we've had one very, very large health insurance company do internal benchmarks. And for those result sets that we cache, they typically see, when they set up, kind of a dummy workload, if you will, it better than 100 times faster return of the result set to the program than Db2 itself would return it. And CPU consumption is around 10 times less. And when you average these savings across those SQL statements that we do treat, when you average these savings across the entire Db2 workload, it can be a substantial figure. So there's a key concept here, that being that some of your Db2 SQL workload is more efficiently handled outside Db2 rather than within DB2 itself. And we'll talk a bit about that in a couple of slides. In a couple of slides, I'll actually talk about a well-known IBM DB2 solution that employs the very same concept. And we introduced this solution to kind of give everyone a framework to hang what we do off. All right, result set caching. So again, we cache result sets. We do not cache entire tables, only the result sets, which means that the physical memory that we need above the bar is, in general, for most shops, a very modest amount. We only cache repetitively requested result sets. No sense in caching a result set that is only going to be asked for, is not going to be asked for again. So typically we'll look for a traffic pattern that indicates that unique SQL has requested a result set 3 times in a row. This is a parameter that you can vary up and down. Once we hit that threshold, we'll then go ahead and cache that result set in anticipation of it being asked for again. Our cache is dynamically populated in real time, which means that when you turn QuickSelect on or turn it off, when you turn it on, the cache will start to populate as we see this repetitive traffic. When you turn it off, we invalidate the cache. QuickSelect can actually be turned on and off in production with no impact to anything, other than the amount of workload that DB2 itself sees. You turn it on, we start to relieve DB2 of some of its workload. You turn it off, that workload heads back to DB2. And I think this attests to the fact that QuickSelect is plug and play in the sense that it is a non-intrusive solution. When you implement QuickSelect, you don't have to change anything in the environment, and I mean anything. You don't have to change DB2, you don't have to change your JCL, you don't have to change any of your application code. It's a completely transparent install. The only DB2 change we require is the addition of a couple of tables to support data that QuickSelect captures. So again, key concept, we intercept, cache, and return result sets. We're not a DBMS in any sense. We're simply a result set caching mechanism. We don't do any of the hard work done by the DB2 database management system. We're stealing the end result of all of DB2's hard work and storing it for your future advantage as these result sets are requested down the road. All right, let me move. Which queries for QuickSelect? This is, a hypothetical workload simplified. A sec here. Most SQL executions in the shops we deal with take only milliseconds of CPU to execute. And as a result, the focus is often in the elephants. How can we go about tuning the big queries out there, perhaps reports that may still be running in the production environment, or other very large queries, the online analytical processing or complex SQL. These are the SQL that get all of the attention, because often the assumption is, particularly when it comes to static SQL that have been bound, have been tuned, have had the heck tuned out of them over time, that there's not a lot left here. There's no low-hanging fruit left in the the small static SQL executions. And we change that equation. Simple selects can be very repetitive. And as a result, if you aggregate these repetitions over time, here we have 4.2 hours of CPU in total due to the repetition of an otherwise fairly innocuous singleton select. So if we can, with QuickSelect, offload this CPU and improve performance at the same time, we have a win. And this is what we do. We kill the swarms of mosquitoes. So not only do you have a tool, which we'll talk about in just a moment, that can deal with the elephants, but with QuickSelect you have a mechanism to kill the mosquitoes. And that tool is IBM's Data Analytics Accelerator. I don't know if you all are using this or if you've trialed it in the past.
No, we actually are using it.
Oh, wonderful. So again, a great conceptual framework because the way IDAA works is very analogous to the way that QuickSelect works. At a conceptual level, it just treats different parts of the workload. So again, IDAA is a great elephant hunter. QuickSelect kills the mosquito swarms. They focus on the opposite ends of your SQL workload, with some overlap, of course. IDAA moves heavy OLAP and analytical SQL off the DB engine onto, in this day and age, IFLs, if you've moved away from Netezza. It's a plug-and-play appliance, hardware-based in the sense today that you're using IFLs to support it. Seamlessly extends the capabilities of Db2. You're copying data from DB tables. You're not moving it. This data is not being removed from Db2. And it preserves full data integrity. QuickSelect. Likewise, services repetitive selects outside Db2, plug-and-play appliance, purely software, seamlessly extends the capabilities of Db2. We're copying result sets from Db2 tables. We're not removing those tables. And again, we preserve full data integrity. This is a simple example of whole workload daily savings at a large commercial bank that managed with QuickSelect to avoid 31% of its SQL hits against Db2 over the course of a day on average, saving over 1 billion hits against Db2. Okay, data integrity. So we build in a concept called update sensitivity. And the mechanism is sophisticated, but in short, what we do is prevent any possibility of data integrity issues or dirty reads due to our cached result sets getting out of sync with the underlying data within the Db2 tables. The cached result sets will always, without exception, mirror those that would be returned by Db2 itself at any point in time. We're update sensitive and we're utility execution aware. Utilities that update Db2 or SQL that update Db2 will be detected instantly, and either activity will cause QuickSelect to invalidate all of the result sets within cache that are derived from the table or tables that are being updated. And at that point in time, QuickSelect will start to dynamically repopulate the cache from the tables as it's seeing the future repetitive SQL statements. Here's a question we're often asked. I have all my Db2 data in buffer pools. Db2 is fast. Why do I need another cache? Okay, and the answer is Db2 has a fairly long fixed code path that you need to execute to get any answer from the database management system, even when the data is in the buffer pool. Right? I kind of liken this to, a very high cover charge at an expensive nightclub. You can go in and you can ask for a drink of water, or you can ask for a glass of champagne. It doesn't matter. You're going to pay the very same cover charge to get that drink. QuickSelect, in contrast, has a very short code path length to retrieve the same result set from its cache. Folks will ask, how do we measure the savings? So the easiest way to measure the savings is by not worrying so much about how much QuickSelect costs, but rather measuring the net benefit, the net savings in your applications. There is a little bit of QuickSelect CPU consumption, but in the applications, take a look at the net CPU savings. How fast are your Kix transactions running faster? Are your batch programs executing more quickly? There's a QuickSelect started task that itself consumes very, very little CPU. This is measurable directly. And you can also directly measure the net CPU savings within Db2. Now, I understand from the questionnaire that Robert filled out before the presentation that you all have, I think, a fairly robust test/QA environment where you're able to run workloads. The same workload, do an A and B test against the same starting database, perhaps with QuickSelect on and then again with QuickSelect off. This is a perfect environment for testing the net effect of QuickSelect against both performance and savings. Okay, more basics. We treat static SQL singleton selects in full cursor statements read operations. Full cursor in the sense that we need to read from the start of the cursor statement all the way to the end of it. Typical cache size is small, ranging from 1 gigabyte to 5 gigabytes per Db2 instance, and we support data sharing across the sysplex, again with full respect for data integrity, full update sensitivity. Survey and proof of concept. So QuickSelect has two modes. It has a survey mode and it has a save mode. The first mode you will run QuickSelect in will be survey mode. And in survey mode, QuickSelect is simply observing the Db2 workload for the repetitive patterns of SQL execution that we treat, those that are suitable for caching by QuickSelect. And from that survey period, which could be a week of time, you can survey both batch and kick separately. From that survey period, we'll generate reports that will show you which SQL statements, which programs, which tables are experiencing the greatest number of prospective cache hits. And by cache hit, in QuickSelect world, a cache hit is an instance of a program receiving its result set from QuickSelect rather than Db2. So we'll generate reports that will show potential cache hits based on the traffic patterns that we're observing. And you can then slice and dice those reports to see which of your SQL represent the top savings, which of your tables represent the top savings, what your total savings are across your applications, across your batch cycle. So again, we give you all of this data without actually having to turn on caching. Now, because you have a robust test environment or QA environment, the next step in your situation would be to, once we've identified those tables, would be to then identify those tables to QuickSelect as being tables that QuickSelect is allowed to cache result sets from, and you have control over that. Identify those tables to QuickSelect, and then you turn QuickSelect on in save mode. Again, this would be in test or QA, and QuickSelect will start to do its thing. So again, if you have the tooling in-house to do the before and after measurements, Db2 performance monitor, main view, CA detector, many of them can do the job. You can get a very good sense for the actual savings that QuickSelect is delivering. So the survey again identifies tables suitable for QuickSelect caching. The only local knowledge that we need that's not delivered directly by QuickSelect is for a Db2, an application Db2 perhaps, to take a look at the list of prospective tables and to tell us which of these tables is relatively stable. Perhaps it's infrequently updated, perhaps it's updated at only one point during the day, and infrequently, by the way, is relative, and we can discuss that at a future point. But here we're looking for the relatively stable tables, and those are the ones that we'll identify to QuickSelect. QuickSelect survey is very low overhead, suitable for surveys in production, generally 1 to 2%. And again, it's not something that you leave running. And we deliver quantifiable results. Now, I'm not going to talk to this slide. I'll just let you read to these three examples, these three success stories.
And Mark, you didn't mention who is doing this configuration. That would be a DBA that is doing that, correct?
You're a good straight man. I'm getting to that in my next slide.
Oh, okay. Any questions, guys, so far? Don't be shy. Just ask questions. We're very open to answer them immediately.
And if anyone's asking a question, be aware that most folks are on mute right now. Okay, the installation, it's a simple SMPE install. The package comes with an installation verification program. And the initial setup and cloning of QuickSelect across LPARs is via an ISPF interface. Everything is via an ISPF interface. Installation roles, the OS system programmer for the install, create the started task, workload manager settings, and APF authorization. Can't overemphasize the latter. I do not think we've had a single POC in the past couple of years where the roadblock we run into once we get going is a lack of suitable authorizations, be it APF or RACF or whatever you happen to be using. Db2 DBA to implement QuickSelect specific tables. There's just a couple of them. And then again, the security administrator for product authorizations. We've had customers with all three of these roles involved. Smaller customers install in no more than a calendar day. Obviously, you have to coordinate activity between these different roles. The calendar length of time it takes to install really depends a lot on availability of this resource and any change control processes that you have set up internally.